All right. So ironically, this next unit is sound. So the first thing that we need to establish is like, what is sound? How does it work? And so this is pretty intense in terms of vocabulary. So the first thing that we need to figure out is how sound itself works. And sound is a wave. Okay? So there's two types of waves. You have longitudinal and you have transverse. Okay? So if it's a longitudinal wave, which is what sound is, what happens with that, and you kind of take sound for granted, but what makes sound work, let me get you quick. Now you can kind of have the visual on this. So this is just that wine glass. I just got a piece of parafilm stretched over the top of it with some salt on it. And so we're going to spend a lot of time with tuning forks. And they have like a certain frequency, like this is 808. So that's the frequency that this vibrates at. So if I hit this, okay, you hear that? Okay. So what's happening is that this tuning fork is vibrating back and forth very, very rapidly. Okay? And to show that, if I take this and I just barely touch it to that surface, you can see those crystals begin to jump. Okay? Because what's happening is that tuning fork, as it vibrates back and forth, is hitting that surface and it's causing that surface to vibrate. So air is acting like that surface. So if you look at the mechanism for me to say, okay, hey, I'm going to give a lecture on sound. All right, so my brain has decided I need to say the word sound. Okay? So in the neural cavity, somebody, somewhere, some neurons are connected, yes.
What words are those?
Huh?
What does that say?
Longitudinal and transverse. Okay? And so in the neurons of my mind, I just said, okay, we need to talk about sound. So then my brain sends a signal to my vocal cords and my mouth to say, hey, we need to somehow form this word that you all can pick up as sound. So my vocal cords vibrate, I say the word sound. So that's sent out as a longitudinal wave. So on a longitudinal wave, it's a series of compressions and what we call rarefaction. Okay? So compressions and rarefaction are the simple side. Hey, so like when that tuning fork vibrates this way, it pushes the nitrogen and oxygen molecules together. When it pulls back, it basically creates like a low pressure system. And that's what we call a rarefaction. So you have a compression and you have a rarefaction. And so that difference in air pressure is transmitted through the room. So then your eardrums get that compression and rarefaction, and your eardrums vibrate. A certain method, they vibrate. That goes through your inner bones of like the saddle, and I don't know what all the inner ear bones are, but those vibrate, and then that sends a signal to your auditory nerve. Your auditory nerve sends a signal to your brain. Your brain recognizes this signal and goes, oh, Bergkamp is talking about sound. So it's pretty cool if you think about it. Everything that you've heard has just been a compression or rarefaction wave that hits your eardrums vibrate. Your brain has been trained to recognize that series of vibrations as the word sound. Okay, now, so what changes is basically the magnitude of that compression and rarefaction. So if I yell like this and I say the word sound, okay, still the word sound, but what's happened is that I've increased the amplitude, I've increased the intensity of that compression and rarefaction. and then that intensity is then transferred to your eardrums. You go, wow, Perkins yelling, okay? Because I'm not sending out much energy. It's still a wave, but that energy is much smaller. So your eardrum doesn't vibrate as much. You go, oh, okay. So that's going to be the difference. So any sound is a compression and rarefaction. Now a transverse wave, which I'll show you in just a second, this is how light goes. So in a transverse wave, you get a signal that goes like this, right? So in a longitudinal wave, the wave travels parallel with the direction of the energy. So when I say the word sound, the energy is going this way, but the compression and rarefaction are in the same direction. Light, when it goes, that energy is actually going at a 90-degree angle to the direction of the energy. So this is why it's called a transverse, because it's at a 90-degree angle. So let me show you what that looks like. So Mara, you'll need to take that camera, like stand up, because I'm going to go back there on that floor, back here. All right, Daphne, I need your help. Bring the chair, Daphne.
You want me to bring the chair?
Yep.
Can I unplug it?
It makes it easy. Yeah, you can unplug it. You should have enough back.